All right, guys, today we're going to be working on starting our three-dimensional section of our geometry unit. We're going to be looking at all the different shapes, all the different types of volume. And after that, we're going to look at how to find surface area, which is a two-dimensional measure of a three-dimensional shape. And we'll take a look at that second. So we're going to start by looking at, we got 6 lessons, 3 volume, 3 surface area, and then again we have actually one more after that. So I apologize, 7 over compound volume of compound shapes or compound figures. So let's start with volume of a rectangular prism. Let's get some vocabulary out of the way. Let's start with what is a three-dimensional figure. And again, anytime you need to pause the video to get the written down, I'm going to go through these relatively quickly. And you can pause them to write down the words in your sentences. So a three-dimensional figure is a solid figure or an object that has 3 dimensions, hence the name three-dimensionals: length, width, and height. That's really what we're looking for. It doesn't have to be solid. It could be like, so for example, a water bottle, which is hollow on the inside, is that, or a cup is a three-dimensional figure, but those are still referred to as three-dimensional figures. A prism is a specific type of three-dimensional figure where it has plane faces, so flat faces, and the bases are identical and the sides are rectangular. So really the key to this is we have these 2 pieces, identical bases and rectangular sides. Those are really what we're looking for, and there are tons of different types of prisms. Every single type of base figure you can think of, from triangles to rectangles to squares to pentagons and octagons and dodecahedrons, all can have a prism, but as long as they have 2 of the exact same bases and rectangular sides connecting those 2 bases, it is a prism. A specific type, and one of the ones we're going to be looking at today, is the rectangular prism. It's made up of 6 faces, 2 quadrilaterals as bases, and 4 lateral faces. And so we have 4 lateral faces, and you can picture that's pretty much any 2-dimensional, 3-dimensional shape, like a table, a cereal box, a tissue box, a book. These are all rectangular prisms. It's actually probably one of the most common 3-dimensional shapes you'll find. From here, we've got one of the things we're going to move on to is the idea of what volume. Volume is the measure of how much space is occupied by a 3-dimensional shape, and it's always measured in cubic units. So how much space does it take up? Okay, how much, and in other words, that's, so if you have a cereal box, it's how much cereal is inside that box. How much can you fill inside that box? That's its volume. How much can you put inside? A cubic unit is this idea of a unit cube has a length, a width, and a height. So it's used to measure volume. It has a centimeter times centimeter times centimeter, or inch times inch times inch. So we talk about anytime we have 3 things that are multiplied together that are exactly the same, we can use our exponents to say inches cubed. Okay, so that gets our vocabulary pretty much out of the way. Let's talk formula. Okay, so if you think about any kind of rectangular prism, and you guys can picture or see any probably in the room you're at, think about this as it is the base of the object, so whatever you'd have for that quadrilateral base, and then how many of those bases are stacked upon each other, whatever size that is, whether it's inches or feet or millimeters or centimeters or whatever, it's that same shape, and that's really what we're looking at. So there's 2 ways to do it. One you should be relatively familiar with is length times width times height. That's a pretty common version of it. It's used in a lot of elementary schools. And then we have another one, which has this big B. The big B is actually the key to this. It actually means the area of the base. So you use your area formula you came up with. So if it's quadrilateral, it's with 2 parallel sides, it's base times height. The 2 that are perpendicular to each other, and then the height of the figure, how many stacks above you are, okay? So let's take a look at what that might look like. So if we find the volume of this rectangular prism, we'll switch to a nice bright color so it's easily seen. We'll use white, should be a good color choice. So we can do it both formulas, length times width times height. Okay, it's 12 times 10 times 6. And again, the upside is you can do this in any order you want. You can do 12 times 6 is 72 times 10, or 10 times 6 is 60, 60 times 12 is 720. Any way you want. It really doesn't matter. 12 times 10 times 6, it works any way you want, but either way, you're going to get 720 centimeters squared. Now, the other side of that formula is big BH. So big B is really just another way to say these 2 together. So the area of that base is 120 times 6 is 720 centimeters cubed, not squared. I don't know what I was thinking. Okay, your turn to try this one. Find me the volume of this rectangular prism. All right, since you've unpaused the video, let's set this up. So volume equals 10 times 5 times 8, if that's our traditional formula, or volume equals 80 times 5 with our big BH problem. So again, it's the exact same formula. It's 400 meters cubed, or we have, again, that same 400 meters cubed on this one. So that's our volume of a rectangular prism. All right, let's try another shape. Let's look at a real dimensional shape. This time we're going to add fractions to our thought process. So it doesn't change anything. It just means we're going to be working with fraction multiplication. And it's still all multiplication. So, and since it's given to you in fractions, it wants your final answer in fractions. Okay, so that's one of the things I want you to kind of keep in mind. The answer must be in the original unit, or in the original type, original form. So if it's fractions, it's fractions. If it's decimals, it's decimals. If it's whole numbers, whole numbers. So we'll talk about this. So same setup formula. Volume equals, we'll use length, width, and height to start. 8 times 3 1/4 times 12 1/2. So we know we've got to change everything to improper fractions. So 8 times 13 over 4 times 25 over 2. So we can cross-reduce still. We can still do our math and think through our cross-reducing, even though we're all here. And we can cross-reduce starting here at 4 and 4, that's 1, and this is 2. Then we can cross-reduce once again down here to 1 and 1. So really what I'm left with is 13 times 5. 13 times 5, that means I have no fractions to deal with, which is great. So I have no fraction answers. 13 times 5, well, that's 325 inches cubed. And if we do big BH, we have the same structure. This time it's 28 3/4, so 13 times 8 divided by 4. So we go down to 2, so 26 over 2. And then we'd multiply it by big BH of 25 over 2. This would be our big BH formula. And again, okay, we'd be able to solve this one. Sorry, it's not 26 over 2, I apologize, just 26. And then we could cancel it down to 13 and 1, and then we have the exact same problem we had here as 13 times 5. All right, it's your turn. Now we're starting with decimals, so you get to do the decimals. All right, now that you guys have done your math, whether you used your volume equals length times width times height, 7 times 11.5 or 11 5/10 times 3 5/10, okay? Or you've used your volume equals big BH, so that's our volume equals 80 5/10 times 3.5. That gives you your final answer of either one is 281 75/100 inches cubed. That's how much you can fit inside that shoebox. All right, now let's work the other way around. Let's work our way backwards. So we can do this either way. This time now I've got the volume. I'm going to plug it into my formula. I can do either one. I'm going to, again, continue to do it both ways. I don't care which formula you end up picking. The big BH is actually the more useful one because it's the one that derives all the other formulas are derived off of. So that's your better formula to work with, but you can use either one. So if I do volume is 84 is equal to 4 times 6 times h. That's my formula to start with this one. The other one would be 84 is equal to 24h. Either way works. So you'd end up getting the exact same problem, and you'd find out that the height of the box in our case would be, so the height would be equal to 3 5/10 meters. Okay, it's your turn to give this one a try. All right, so either, this time it's a little hard to use big BH, but you can still use the idea of big BH by saying the base is a different shape. So you could still put together 20 and 8 and say 960 is equal to 20 times 8 times W. There's one formula type. Or you could say 960 is equal to 160 W and solve either way, dividing by 160. Or in this case, again, that same 160 leading me down to W is equal to 6, in this case, centimeters. All right. That's really volume for us. If you have questions, please feel free to reach out. I'd be happy to help you.